All right, this is section 11.1 and 11.2 kind of mixed together because it's just recapping areas. Most of these formulas you've already done in your past, and then today's just kind of like a review. So the area of a square, the two sides are the same, so they'd both be s's, and sometimes it's written as s squared. You guys would probably more know it as base times height. Make sure that looks like a times symbol and not a minus sign. Sometimes it happens. Or write them in parentheses so you make sure that you know to multiply. Rectangle is the exact same formula, so base times height. Parallelogram is really just a rectangle tilted, so that is also the same formula, base times height. Triangle starts off the same, base times height, and then you just divide by 2. A circle, remember that you're talking about the radius of a circle when we use our formula, but it is pi r squared. Trapezoid has two bases that are parallel, so base 1 and base 2. Those are what we're going to use in our formula. So we're going to do base 1 plus base 2, and then you multiply by height, and then in the end you chop it in half, or divide by 2. Rhombus and kite are actually the same formula. They are both 1/2 and then diagonal 1 times diagonal 2. And we just need to talk about what those diagonals are and how we're going to end up finding them. So any diagonal is drawn from one vertex to another vertex, or one corner to another corner. So this would be a diagonal, and then up and down would be a diagonal. Same with kites. What's interesting about both of these is, if you remember back to chapter 8, when diagonals meet each other in the center of a rhombus or a kite, they actually make a 90-degree angle, which means we're going to be using a squared plus b squared equals c squared quite a bit. And we're going to actually do that in a problem today. So sometimes in order to find the diagonals that we're going to need, we're going to have to use Pythagoras. We've got 8 examples down here, and we'll just spend some time matching them up to each shape and then using the formula. So this is a parallelogram. It's just tilted sideways. So if I tipped it like that, maybe more like that, this could be our base. If you leave it like this, which some kids did, they saw 6 as the base, so I'll set it up both ways. So if this is going to be your base 6, then your height has to be this, which is 8. If you wanted to turn it, which some students did, then they found 12 is the base, and then 4 would be the height. And in either case, when you do the math for that, you get 48. There was no label on these, so we're just going to go with units squared. Next up, I've got a triangle. Make sure that when you're doing area of a triangle, you trace the entire base. So the whole base of this is 45 plus 21, which is 66, times height, which is 28, and then we're going to divide by 2, so I end up with 924. Again, no label, so just hit it with the units squared. Next up, I've got a parallelogram, another one, same as number 1. Base times height is all I have to do, so base is 17 and height is 7. Didn't need that 10 in there. This is 119 units squared. Radius is 2, so in order to find my area of a circle, I would do pi and then 2 squared. 4 pi is a totally acceptable answer, and that would be yards squared. If you wanted to multiply that out, you would get about 12.57. If you round, still yards squared. Next up, I've got a rhombus. So the formula for a rhombus is area equals 1/2, and then we need the 2 diagonals. So this 11 is just pointing to this part. And in a rhombus, the diagonals bisect each other. So if that's 11, then this is also 11, so that's 22. If this is 8, then this is also 8, so the whole thing would be 16. And then we just plug that in, multiply that, we would get 176, and this one has some labels, so centimeters squared. Next up, I've got a trapezoid, so we're looking at this formula. So I've got area is 1/2, and then my 2 bases are 7 and 9, and my height is 4. Plug that in, and you get 32, and we have labels here, so feet squared. Next up, we've got a kite, so area is 1/2, and then we've got our 2 diagonals. So first diagonal's right here. Actually don't have any numbers on that one, so don't know anything about it yet. This diagonal, I've got a 20 there, which makes this 20, so the whole thing is 40 for that one. And it looks like we're going to have to do some Pythagorean's theorem to figure out these 2 measurements. So this triangle, I'm just going to kind of write it right here. This will be 20, and it's the same, the hypotenuse is the same as this tick mark, so that's 25, so we're going to figure out what that is. 90's right there. And then this triangle has a 20 right there, 35 out here, and then we're going to figure out what that is. So doing 2 different Pythagorean's theorem. So this one would be 25 squared equals 20 squared plus y squared. This one would be 35 squared equals 20 squared plus x squared. So, grab my calculator. This first one is 25 squared. and then we're going to minus the 20 squared off of it. So you end up with 225. Don't forget that you're going to have to square root that. So we found out that this y right here is 15. Now this does not look the same as that one. So in a kite, one diagonal is cut in half, bisected, the other one is not. So since we already claimed that that was 20, this is 20, then it means this other segment is not bisected. So that's 15. We got to figure out what this one is. I'm going to do 35 squared, and then I'm going to minus the 20 squared. And then same thing, I'm going to need to square root that. This one won't come out clean. We're going to get a decimal for it, which is okay. So 28.72. So that's this right here. And then our 15, oh, I already filled it in. Our y, that goes right there. So our whole diagonal is the 15 plus the 28. So I'm just going to add 15 to that. And we get about 43.72 times by 40, and then cut it in half. And we get about 874.56. Whoops, 46. I missed that whole 4 right there. 4, 6. No labels, so we'll go with the unit squared. One left. This one you actually get the area, and you're supposed to find the base. So I'm going to set up the formula for area of a triangle, which is 1/2 base times height, or base times height divided by 2. Either one will work. Area is 399, so that's what's going right there. And then I've got half, and then my base is x, and my height is 21. And now it's just an algebra problem. So I'm going to multiply both sides by 2. And get rid of that 1/2 right there. So I've got 798 equals x times 21, and then just divide by 21. So it looks like my x, or my base, is 38. And we were in inches, so that can be in inches as well. So hopefully this is an easier review lesson for you. These are all formulas you've done before. I think the trickiest ones you're going to have are the triangles for sure. Make sure you're doing the whole base. And then anything where you're going to have to use some Pythagorean's theorem.